Voyager 1 is older than the Internet, older than most modern computers, and more than 15 billion miles from Earth. For decades, it has continued transmitting tiny amounts of information from a region no human spacecraft had ever explored before. But in late 2023, something went seriously wrong. Voyager 1 was still communicating with Earth, but the information coming back was no longer usable. Instead of meaningful engineering data, the spacecraft appeared to be sending corrupted information. For a mission launched in 1977, this could have been the beginning of the end. Engineers eventually traced the problem to corrupted memory in the spacecraft's flight data system. The challenge was extraordinary. Voyager 1 was so distant that every command required many hours to travel between Earth and the spacecraft. There was no possibility of a quick repair. Instead, engineers had to carefully reconfigure the spacecraft from billions of miles away. Their efforts worked. In April 2024, Voyager 1 once again began returning usable engineering information. The spacecraft had effectively survived another crisis. But Voyager's greatest story is not the malfunction. It is where the spacecraft is now. In August 2012, Voyager 1 crossed the heliopause, the boundary where the solar wind gives way to interstellar space. Scientists expected this region to be complicated, but Voyager revealed just how dynamic it could be. The spacecraft detected changes in plasma, energetic particles, and magnetic fields. Far beyond the planets, space was not simply an empty darkness. It contained a thin environment of charged particles and magnetic fields that could still be measured. One of the most fascinating discoveries came from Voyager's plasma wave observations. The spacecraft detected oscillations in the surrounding plasma, allowing scientists to study the density of interstellar material indirectly. These signals are not evidence of a cosmic intelligence or an alien transmission. They are natural physical phenomena. But they are incredibly valuable because Voyager is directly measuring them. Telescopes can show us distant stars and galaxies. Voyager can sample the environment around itself. That makes it something completely different. It is a scientific probe traveling through interstellar space. And its measurements are helping scientists understand what lies beyond the Sun's enormous protective bubble. Voyager has also shown that the transition into interstellar space is not simply like crossing an invisible line. The environment around the heliosphere contains changing particle densities and magnetic conditions. The Sun's influence continues outward, while the surrounding interstellar medium pushes back. Somewhere in that enormous interaction is the boundary Voyager is studying. And now, nearly half a century after launch, the spacecraft is still moving outward. Its instruments are slowly being shut down as its power supply declines. Every remaining measurement therefore becomes increasingly precious. Because Voyager the 1st of May eventually lose the ability to communicate. When that happens, humanity will no longer have a functioning spacecraft directly sampling that distant region. But before that day arrives, Voyager still has one more story to tell. And the next chapter begins with a simple question. What is actually waiting beyond the Sun? Beyond the heliosphere lies an environment that humanity can only study through a handful of instruments. Voyager 1 is one of those instruments. Its journey has revealed that interstellar space is not completely empty. It contains plasma, magnetic fields, cosmic rays, and energetic particles moving through an enormous and extremely thin environment. Some of the most important measurements involve the density of plasma around the spacecraft. When disturbances travel through interstellar plasma, Voyager can detect the resulting effects with its scientific instruments. These measurements allow researchers to estimate conditions in the space between stars. And that gives us something remarkable. For the first time, humanity is not simply looking at interstellar space from a distance. We are sampling it directly. Voyager 1 has also detected changes in energetic particles as it moved beyond the heliosphere. These observations help scientists understand how the Sun's protective bubble interacts with the surrounding galaxy. The heliosphere is important because it helps shield the solar system from some forms of energetic radiation. Understanding its boundary therefore tells us more about the environment surrounding Earth, even though Voyager is unimaginably far away. But Voyager's greatest limitation is becoming increasingly obvious. Power. The spacecraft's radioisotope power system produces less electricity as time passes. Engineers have therefore been forced to shut down instruments and systems to preserve the mission. This means Voyager is slowly losing its ability to observe. Eventually, there will be too little power to operate the remaining scientific instruments and communication systems. The spacecraft will then become silent. But its silence will not mean that the mission failed. Quite the opposite. Voyager 1 has already traveled farther than any other human-made spacecraft. It visited Jupiter and Saturn. It transformed our understanding of the outer solar system. Then it crossed into interstellar space and began measuring an environment humanity had never directly explored. Its data helped demonstrate that the boundary of the heliosphere is far more complex than a simple wall. And perhaps the most remarkable part is that Voyager is still moving. Long after its scientific mission eventually ends, the spacecraft will continue drifting through the Milky Way. It will carry the famous golden record containing sounds and images representing Earth. No human may ever recover it. No future astronaut is likely to encounter it anytime soon. But it will remain a physical artifact of a civilization that once looked toward the stars and decided to send something outward. Voyager 1's greatest discovery may therefore not be one mysterious signal or one impossible measurement. It may be the realization that the space between stars is itself a place worth exploring. There are magnetic fields we cannot see. Particles we cannot feel. Plasma waves we cannot hear. And boundaries we cannot physically touch. Voyager has spent decades translating those invisible phenomena into data. And every usable transmission is another piece of information from the frontier. One day, that transmission will stop. The signal will become weaker. Then weaker again. Until Earth hears nothing. But Voyager 1 will continue traveling. And somewhere in the darkness between the stars, humanity's oldest interstellar explorer will keep carrying a simple message. We were here. We looked outward. And we wanted to understand.